Before we do that, however, I want to explain a little bit about the general structure you have of a behavior tree. Why do you place something to the left? Why do you place something in the middle? Why do you place something to the right? The way to understand this is that you place your tasks in an order in which it is prioritized. So this sequence over here, for example, if we were to name this, would be something like chase player. Now, disregard the nodes below for now. So the highest, actually, let's do it like this. The one thing, let's say that this is an enemy character and it wants to kill our character. We are sneaking around in an enemy base and they want to kill us. That's the general purpose of the AI. So the thing it wants to do the most in the world might be attack the player. And that's what it's going to be doing if it can. If it can't attack us, then it maybe wants to move to attack location so that, oh, that's not right, so that it can actually attack. So if this one fails, it can't attack, it will go to the next node, which will make sure that it tries to get to an attack location so it can attack the player. If it doesn't have an attack location to move to, maybe it would have something like investigating suspicious behavior. I was about to type in, but that was too long, so let's just type in investigating for now. So if it doesn't know of a player, then it might be going around investigating sounds or something like that, if it heard some sounds. If it hasn't heard any sounds at all, let's make another sequence, then maybe it would have something like patrolling. And if it doesn't feel like it should be patrolling right now, it might be having something like idling. So from this, I hope you get the understanding that the task to the furthest right is the one that it wants to do the least, sort of. But this one is important. You always need to have some sort of fallback to your AI, so it has something to do at all times, and don't end up in a situation where everything is failing. So some kind of fallback, and this can be just a simple thing like having a wait for 1 second or something like that, like so. And then it will try to do the higher ones, and it wants to do this one, but this one, for example, it can only do if it has an enemy spotted, right? So let's add something called a decorator. So decorator is something you can add to your tasks. Right, I haven't mentioned that, I'm sorry. These purple ones are tasks. You have a few available to you by default by dragging out like this. You can see under the tasks here. These are the ones provided by the engine. If you wanted to, you can also create your own tasks. It is not super difficult, and you can place whatever code you want inside of there, and then you can have success states and fail states in them to make sure that it's being properly communicated to the behavior tree how it's supposed to be proceeding. We'll be getting back to that in a moment. But for now, yes. So a decorator is when you want to add something to a task or a sequence or a selector, making sure that it can only do that logic under certain circumstances. So if we were to add a decorator to attack player, for example, we could add a decorator here, and we could add one of these different things here. And one of the things that we could add is, let's see here, I'm assuming it's going to be that one. So blackboard based condition, and here you can see I want to change the decorator. Let's see, where is it? Self actor is the the key that it's currently checking against, and we want to say, for example, enemy spotted. And here you can say is set or is not set, meaning if it has a value or doesn't have a value. Since this is a boolean, then is set would be being true then. So if we were to have this, it would come here, the selector would come here, and it would check, is the enemy spotted variable over here set to true? Then it can do these things. Otherwise this will fail automatically up here. You don't even need to check over here if they're failing, and then it will just move on. Let's see if we can demonstrate that a little bit. Like so. And we have our character. I'm gonna run out of screen real estate real bad here. So we have our character over here, and you can see immediately that on the right it's already hammering on the move to attack location instead of the attack player sequence, because by default, like if we check in here, we can see that the enemy spotted is false. If we move into the enemy spotted is in the sight range, we set the enemy spotted to true, and now all of a sudden this part of the chain is available for the behavior tree to reach. Okay, so how do you generally work with a behavior tree then? Well, it tends to be not that advanced. Well, it behooves you to try and make it as simple as possible, both for the understanding of the behavior tree, but also to alleviate complexity from the behavior tree. Again, because behavior trees and AI in general is more performant in C++, you need to be a little bit careful when you're doing it in blueprints, because it can easily take a lot of performance away from you. But let's create some logic. So let's have some other stuff here. We have a move to location here. Let's remove this one. And in this case, we have an enemy location created over here, even though we're not actually using it yet. But we can say this move to over here should be using, you can see what kind of a key it's going to be using here. It has a self actor by default. You can change to an enemy location. You can also notice that we're only seeing 2 keys in here. That's because this one wants to have a position in space to move towards, and you can see also moves the AI pawn towards the specified actor or location. And the self actor reference here is a reference to the actor itself, so the AI, and this is a vector, meaning that these are the only 2 valid keys that this one can make use of. The boolean doesn't work. So we can change this to the enemy location, and you see that this task is now updated, and it says it's supposed to move to the enemy location. So if we were to do this now, you can see that nothing is happening for the AI until we jump up in front of him, and you can see, hold on, let's see if I can get this. Here, move to location is being tried. Actually, let's see if I can get the window to... Okay, I'm having a real problem with my screen real estate. I'm so sorry about that. So you might wonder, why is it flickering? Why isn't it moving? Well, what's happening is, I didn't show it though, but in the beginning, I showed it a little bit earlier, it would be failing because the enemy spotted was not set in the beginning. So it would be hammering in here. But then we have entered the position where it actually is. Are we not showing the... Why is the... Okay, it's not showing the information right now. Might be because... Character, there we go. So now we have the... I'm sorry, the character controller was selected in the world outline. And you need to have the character, AI character, to get all of its information available here. So then now you can see that we have the enemy spotted true, which means that it's allowed to go in here, and then it's doing the move to here. And then you can see that it's actually going out and going into here, and then it's trying this again, and then it's failing and going up here. And that's because we don't have an enemy location set. You can see here, enemy location invalid. You can also see it up here, enemy location invalid. So that means that this node is failing, communicating it upwards. The selector gets to hear about it and says, well, I don't want to do this branch anymore, I want to go to this branch. So it tries to do this branch. And then that succeeds, and then it goes back to trying to do this one again here. And the reason for this is, well, pretty obvious. We have not actually at any point set what the enemy location is supposed to be. So if we were to go to our AI character, we have a stimulus over here, and if we determine that we have, for example, detected the player, then we might want to move to its stimulus location. So in the same way that we created a set value for bool here, we can also make a set value for vector, since that is the location. And we put in the stimuli location over there. And we can make a literal over here. And we can put in the variable name that we're after, which is enemy location. Let's go in here so I can copy paste it and get everything correctly typed. Like so. So now what we're doing is, if we are at any point detecting a player, meaning this condition is true, we have sensed someone with a stimuli, we're going to be setting our enemy as being spotted, and we're going to be setting the enemy location as whatever the stimuli location is. So let's demonstrate this. We walk in front of this character, and you can see it immediately walked towards where I was. Now this is very basic. You can see what's happening is the character has a vision sense of, let's see, like so. You can see it can see 180 degrees basically. So whenever I move into the range here, so it can sense me, it will walk towards that specific area. Now let's see here if we can get a little bit clearer about how it is behaving. Go back to the behavior tree. You can see it's trying to move to the location, and you might be thinking, well, no, it isn't. I'm over here. Why is it moving over there? Well, because the move location that it has is not the one that I am currently in. Let's see here. I want to have behavior tree. You can see, let's see, there. This is the location it currently has. So that's the location where it thinks I am, or where it's supposed to move to. So I need to move in here again to give it a new, what's it called, location for it to move towards. And now you can see nothing is happening while I'm moving around here. Well, why is that happening? Well, that's because the way that we coded this isn't a really great way of doing this solution. This is just for demonstration purposes. But the only time we're actually setting the enemy location is when the stimulus is true, meaning we have detected him, the player, and also while the stimuli or the perception is being updated. Meaning, if I walk out of range for him here, I need to go outside of the actual purple here. That's when the second. So here an update happened saying the perception has changed. Now I'm not visible for him anymore. This is the last position I was visible. But at that point, I'm not, the stimuli isn't true anymore, which means that we're not setting a location for him. We need to actually enter this area again for it to get that new location being set. So it is thinking that it is succeeding right now, but that's not really the case because of how we have done things. Let's show here. So we get a stimulus for entering the area. We check, is it successfully sensed? And it is. We're setting the enemy to true, and again, since we're never setting this to false, this is just being set the first time, so this is not good ways to do it. It's just for demonstration purposes. But anyway, once we have done this part, we're also setting our value for the player to be wherever it sensed us. And this also works for other things like, oh, that was unfortunate. So what I wanted to do was actually, I wanted to be able to use sounds on him. So we know that if we are standing behind here, he can't actually see us. But if we make, let's see, perception, if we make a sound, he actually came running around the corner, because he, even though it's not showing, it should be showing. The perception is a little bit wonky that way. But also it's not wonky. In this case, I'm actually having the wrong thing selected here. But yeah, I created a sound around the corner over there, and that's why it ran to where I was around the corner. So then it picked up the stimuli for the hearing and went to that location where it was created as well. So this is how you can communicate information, but this is not ideal for this specific case when we don't want the character to just run and chase us when the stimuli is updated. We want to have the character chase us indefinitely, perhaps. So, well, what we can do then instead is we can go to our blackboard, and we can make a new key, and we can make an object, and we can say enemy reference, like so. And instead of in the behavior tree having a move to location of our enemy location, we can set this off to our why is it not updating properly? Let's see if it works if we close it down and open it up again. Or did I not save it properly? I'm not even sure right now. Move to location, enemy location. That should be showing our save. Okay. Maybe I set up the variable incorrectly. So we have self-actor, we have enemy, base class object. I want this to be an actor. That should be better, I think. Yeah, there we go. So this one needs to have an actor location, and it was by default object. An object doesn't necessarily have a location in the world. Anyway, so we can have our enemy reference here instead, meaning that we're setting a reference to a character. So if we go back to our, not AI character, but our third person, actually our third AI character, and we want to change, we don't want to set the value as vector, we want to set value as object, and instead of a position, we want to have the actual object that we're working with. So this is going to be, I think this one is the easiest one. We'll add a reroute node here, and we'll drag this one over here. So what we're doing is we're plugging in the actor, the one that's causing the stimuli to be successful here. That one is the variable that we're sending in here. And again, we make a literal, and we take the name from the blackboard, enemy reference, go back to our character, and we put it in here, not like that, like so. So essentially what we're doing is, let's see here, it wants the blackboard also, like so. So essentially what we're doing, instead of putting a location for it to move towards, now we're saying you're supposed to be moving against this character, or moving to this character. And our character is going to be the same all the time, but its location is going to be different. But this one won't matter because it's trying to move to the character, not the location that it was at before. Which means that it will now be chasing after us regardless of where we move, because it's not trying to go to a location, it's going to the actor, and then from that it's getting the location each time in the blackboard over here. Let's see, like so. Not blackboard, behavior tree, I'm sorry. So it's moving here all the time. And if we check here, we go in here, we go into debug, you can see its animal location is invalid, we're not setting that, but the enemy reference is set. So you can see that it's following us because it always has us set, so to speak. Yeah, I hope that makes sense. So to elaborate a little bit on this further, if we wanted to, we could create a task of our own, and I think this is a good way of teaching this. So let's say we want to have a new task, and a task you create is just like these ones, and you just click new task and you immediately get a task. Compile and save that, and then you have some functions that you can override for this task, and the one that's most prudent for us is the receive execute AI. So this is the node or event that happens when it encounters your task in the behavior tree. So let's first do this, just so we can this is the behavior task that it created. It gets a default name. We can call this blueprint. I'm actually not sure what behavior tree is BT, so we want to have BTT, I think, is behavior tree task. Yes, that is a good naming convention. And we'll call this find enemy or something like that. So when we go into our behavior tree here now, what we can do is we can drag off here and we can see under tasks we have our task now, our behavior tree, find enemy. And that is how easy it is. And once this encounters this task, what is going to happen then is that this node is going to be executed, and you get a little bit of information. You get the controller of the AI and you get the pawn of the AI, so you can operate with those if you wanted to. Now, if let's do something a little bit hacky just to explain and show. What we want to do is we want to have the location of our player character, and we want to follow him around, but we don't want to have it put here into the blackboard like we had earlier. So we have cut off the reference here now, so we're not getting the location set anymore. So if we run in front of the player here, you can see, or the AI, you can see that it's detecting him, but it's not actually doing anything. So we want to set that location instead in our task now. So what we can do is something just hacky, and this is not good form, but just to show that we can do this way as well. We can get an actor by class, yes, and we want to have a third-person character. So we get a third-person character, and this is what we want to have as our variable now. So a way to communicate now with the blackboard in an easier way is we can create a variable, and we can call this enemy found reference. And you make this out of, it has defaulted it for me, but if you don't get it here, you can type in blackboard key selector, and then you have a key that you can use for the blackboard. And how this works is you can drag out variable reference like this, and you can set value just like we did before. If I can type properly, like so. And in this case, we're working again against a actor reference. So we want to have object. We can just hook this up like so. And we connect the found actor to the value here. We need to make sure that this variable is instance editable. So it's available outside. Yeah. And then we have to have, what's it called? Finish execute. And this is the part where you communicate back with the behavior tree about how your task went. So having this set to true means that you succeeded, meaning that the behavior tree knows. Let's go back to our behavior tree a little bit. There. It knows that if this task failed and how to react, if it should be chaining it up somewhere in the chain or if it should move into the next task, depending on if you're on a selector or a sequencer. So that's why you need to communicate that through the success. If you do not provide this node at all, I believe you automatically get a failure at all times. But yeah, so now that we've done this, we get this event when we enter the task. We get an actor, just poorly coded, but for demonstration purposes. And then we set a blackboard value for enemy found reference. And then we say that we have succeeded here. Now, why is this good? Well, going back to the behavior tree, you can see that our behavior tree task find enemy over here now has our exposed variable, which was set to enemy found reference, meaning that whatever we have here is what we're going to be setting for our blackboard. So by default it has the self actor, but we want to have the enemy reference. So we're saying that the value that this one provides, which we set inside the task, should be setting our blackboard value for enemy reference, which then our move will be making use of. So in theory, how this will work now is we come to the selector, it tries to do this, it fails because enemy is not spotted until we move in line of sight, so it's going to be doing this. Then each time it has succeeded in doing that, it will go back here. And if at any point it managed to set enemy spotted, which again we do inside our AI character over here, after we have a successful stimuli, so when we're shown, then we will, by using this task instead now, set our enemy reference, so the actor, not the location, but the actor reference itself. And then since we know that if we have an actor reference to move to, then it will continue to follow, and this is what it will be trying to do. So let's see if that works out. So nothing is happening right now. I move in line of sight and it keeps following me now. So that is how that works. I hope that made sense. So yeah, you can build upon this, and we will be getting back to this and getting more in depth with this later on. But as a introduction for behavior trees, I hope that this makes sense for you to see how you can use both your own tasks and perception to communicate with the behavior tree and the blackboard, and have the blackboard drive the behavior of the behavior tree. Yeah. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.